All right, so one of the tools that we're going to be going through right now is a tool called Netcat. Netcat is oftentimes referred to as the Swiss Army knife for cybersecurity. It's a simple command line utility that's available in Linux, Unix, and Windows. And it's designed to read information from connections using TCP or UDP and do simple port redirection on items that are configured. So we'll go through and talk about what the steps are to use Netcat, and we'll set up a listener on one terminal over on the left here. And this listener is set up to, on my local host, set up to utilize port 5560. And then on a remote host, what I would do is, after I've got the user to download maybe an embedded Trojan or virus from Facebook or Google Docs, wherever they're going to download something to their local machine, what I would do is I would connect to that listener from a remote location, and by typing in the IP address and then the port that I set up the listener on. And then from that, what I should be able to do is I should be able to say hello world over on my side. And it's a full duplex connection here. So what I should be able to do is say, hey, how are you? And hit it on this side and basically type back and forth, whatever I wanted to on this side. Again, on this side, same thing, going back and forth. But essentially, now I have connectivity. And within the Netcat shell, there's a bunch of cool things that you can do. And if you really wanted to learn more about it, you can use the man within Linux to go in and check out everything that you need to know about Netcat. But for our purposes here, this demo is complete.
Okay, so now in this particular case, what we're doing is we've taken off the capture filter, and obviously you're seeing a significantly larger set of traffic, and you're seeing a lot more protocols, you're seeing a lot more activity, and you're trying to figure out how each one of these is configured and how it's working. So what you can do in order to kind of clean it up, in the case where we use the capture filter, we went ahead and we said host equals a IP address, okay? The difference between that and the display filter is if you just wanted to look for an individual IP address, you can do the following. Was it 24.17.42? What was our address? Okay. Yeah, okay. Okay, so now in this particular case, we notice what's going on here. So it looks like 1816 was doing what? Okay, that's all right. So let's take a look at that. One of the things that we had mentioned about the goodness of the way that Wireshark is, instead of having to look at individual packets and try and figure out what's going on, you can right-click on it, and you can have a discussion of, that's once the, and you can look at each one of the replies and requests that have occurred. Do you remember yesterday when we had a discussion about the codes and the types with ICMP? So in this particular case, let's take a look. You'll notice how this looks very much like the looks very much like the OSI model in terms of how things are set up. Your frames, you going down to your IP, then you going down to your protocol that you're utilizing. So in this particular case, since a request is type 8 and it's code 0, then it will help you to understand what it is that each one of those codes and types actually is, right? All right, so we know that a ping request is type 8, code 0. Now let's take a look at the reply. And then see what it says about that one. Okay, so the reply is actually a type 0 and code 0. All right, let's continue to take a look down, see if we got any other information. Let's take a look at one other thing before we do that, now that I look at it. What is this right here? Okay, time to live. So we know that Linux operating systems have a TTL of, okay. What Windows systems? Okay. How about FreeBSD? 255. So what you will notice is you could gather information directly from the TTL values to identify the operating system. And a lot of times in the exam, what will happen is they will go in there and they will say, your network trace look like this, and it'll give you a trace that looks similar to that or in TCP dump, and will say which operating system is X IP address. So if you see the 64, you notice it's Linux. If it's 128, it's Windows. 255, it's the FreeBSD. Okay. Now others have been configured, and there are tools in order to purposefully change it in order to make people think that you're something else. But for the purposes of the test, they're going to ask you what the real value is. So keep those in mind. We enjoying learning stuff here? This is good stuff, guys. We use it every day. I mean, seriously, like a lot of the stuff that we're talking about, when we have to go into a system and be able to utilize this stuff, you just become proficient at being able to do it. And it's a lot of fun. And if you guys have any questions, let me have it. All right, let's take a look at some other stuff here. All right, so we see the same DNS information as we had before. And one of the things that you will notice is, and this is probably just because you spent so much time doing this, but anybody familiar with this IP address here?
Yeah.
What is that?
Google DNS.
Okay, good. And so what's the backup Google DNS number?
8.8.4.4.
Only one 4. 8.8.8.4.
Yeah, 8.8.4.4.
Take a look at that.
I think it's 4.4.2.2.
It might be. Okay. I'll take a look. Can you write that down? I need to check that out then. Okay. All right, let's take a look a little bit further down. Okay. Now we have this one here that's in black. It's an ICMP, and it says destination unreachable. So let's take a look at that for a second. All right, so if you open that up a little bit, if you guys are seeing the same thing we're seeing here. And you'll notice that this one came back as an ICMP protocol, but it's pretty clear that we're dealing with what? What are we dealing with here? Yeah, we're dealing with DNS, but you get a response back that says ICMP, right? And so you remember a discussion yesterday about how DNS, when you're dealing with DNS, it's UDP in nature. When you get responses back, you're going to wind up getting an ICMP response back to a UDP packet. And so that's why you're seeing this occur here, okay? Once again, for the purposes of the exam, the reason why we're going through this step by step is for each one of these protocols, the types of questions are going to be focused on your understanding of the protocol and how it operates, okay? And DNS, once again, those are the types of questions that are very familiar. All right? All right, let's see if there's anything in addition. All right, so it looks like we just continue to have the DNS. So you've noticed that we'll have those DNS and it'll have about 10 entries and then something will happen and then add DNS again. So what does that tell you about the way in which the DNS is operating? Yeah, so there's a certain time frame in between each time it goes out to take a look at it. And it kind of makes sense because, you know, obviously things change. So if something happened that was different, it wants to make sure that it's still going to the right locations and so forth. Okay? All right. So let's go ahead and stop Wireshark for a second. And what I'd like to be able to do here is bring up a command line real quick. And we know the value of Wireshark and all the types of things it can do for us. Let's take a look at another tool that's for the purposes of the command line. And go ahead and type in TCP dump and do a help on that. And so some of the basics of the way Wireshark is configured utilize the same tools as far as being able to see information that's going across the wire. But the difference between this and the way in which Wireshark is configured is this allows you to be able to do your filtering at the command line. And a lot of people, since they got used to doing it over the years, have become very proficient at utilizing this tool versus using Wireshark. Yes, sir.
Can you stop? And then
Oh, yes. Yes, I can. Let's do that. You'll have to edit out that last part.
that way people would